Welcome back. Now we are going to do something very important that is useful to establish credibility of your classified map, that is called as accuracy assessment. Now you have classified a map, but you don't know how accurately you have classified that. So you need to compare your classified map with some information from other source. So what is the accuracy assessment? Comparison of two sources of information. One is remote sensing derived classification map, and the other which you require to have accuracy assessment is the reference test information. Now this reference test information may be an already classified map of a higher scale, or it can be in the form of ground truth information that is collected from the ground regarding different land use land cover classes of the classified map. And the relationship between the two sets of information is expressed and is known as in the form of a matrix, which is called as error matrix or confusion matrix or contingency matrix. Now what is that error matrix or confusion matrix or contingency matrix? This is the example of confusion matrix. See, on left hand side, these are your classification results regarding different land use land cover classes like water, concrete, buildings, bare soils, grasses and slope. And on the right hand side, this is the information which you collected from the ground, or you have it from the high resolution map that is already being prepared and verified by someone else. Now we take one of the examples, like here water, here 93 is given, and the total column total is 97. Here your classification results suggest that out of 97 pixels or the polygons that you have classified, 93 have been correctly classified as water, but two have been misclassified as high buildings, which were water but have been classified as high buildings, and another two were also water but have been misclassified as bare soils. Now this is going to give you the producer's accuracy for water. So how we can understand that this is producer accuracy? W is water, means 93 you have classified correctly out of 97, and the percent becomes 96. This is your producer's accuracy for water. Likewise, you can assess producer's accuracy for any other land use land cover class. And this type of error which we committed is known as error of omission, where 2 and 2 water pixels have been misclassified as high buildings and bare soils. Now coming towards the user's accuracy. Now user's accuracy. Now on the right hand side, it's quite obvious that you know 2 pixels of high buildings and 2 pixels of bare soils, which are genuinely as high buildings and bare soils, have been misclassified as water. Now those were actually high buildings, 2 of them, and 1 was bare soil. Those have been misclassified as water. So you can say the user's accuracy for water becomes the row total is 96. So out of 96, 93 have been classified correctly. Means 93 upon 96 is equal to 97% is the user accuracy for water. Likewise, we can have user accuracy for any other class. This user's accuracy is also known as error of commission. We have committed an error here. And in case of producer's accuracy, we have an error of omission. Means we have omitted 4 pixels here, 2 and 2, which were water, but we omitted these to include in water. But here in case of user's accuracy, we committed an error, that is 2 and 1 pixels were not water, but we classified it as water. That means we committed the error. So this is known as error of commission. And these are the the way, this is the way how use producers accuracy for different classes have been achieved, and this is the users accuracy for all other classes, which may be grass slopes, or F is forest, H is high buildings. Now we want to have an overall accuracy. Overall accuracy is equal to, you can see these diagonal elements. These are the diagonal elements. These represent the pixels which have been correctly classified. Correctly classified for water, correctly classified for concrete, correctly classified for high buildings, correctly classified for bare soils, and likewise. Now this is the sum of all diagonal elements. You can see 1, 2, 3, 4, 5 up to 9, from 93 to 512, and divided by the total number of pixels that were there, divided by 1426, which gives you an overall accuracy of 81%. Now producers and users accuracy can be estimated for each land use land cover class, and overall accuracy is for the overall classified map. Then we have another term as kappa, or Hut coefficient, which has been estimated to be 0.794, and we will try to understand it in the next slide how kappa has been estimated. Now coming to Kappa Statistics, which is equal to K is equal to PRA minus PRE upon 1 minus PRE. Now if we give the classification to be carried out by a layman person, he will also have some of the pixels correctly classified as a matter, just as a matter of chance. Now to make a difference between the chance and the genuine classifier who has information and knowledge about the classification, this kappa coefficient is used for the same. Now what is K is Kappa Statistics, PR is probability of success of classification, that is this term PRA, and PE is the probability of success due to chance, that is this term, and this is repeated in the denominator as well. Now when we further expand it in terms of formula, this in the terms of formula, it becomes PRA becomes N into summation of CMII, that is CMII is the diagonal elements. These are the diagonals. Here you can see the diagonals. These are the diagonal. So we have to multiply N. N is the number of pixels, total number of pixels, means we have to multiply N, this is N, into summation CMI, which is nothing but sum of correctly diagonal values, and we have to subtract it by PRE, which is the probability of success due to chance, which is nothing but summation CI into C corrected and CI predicted, which is nothing but C into R, column total and row total. We have to multiply each column total by row total and get its summation, which is this. So this is the term CI into CI, which becomes 520651 as has been computed here, and we have to divide it by 1 minus probability of success due to chance. Here it becomes n square, which is total number of classified pixels 1426 square minus the same term that was in the numerator 520651, and the kappa coefficient comes out to be 0.79%. So this is to reduce kappa coefficient. After the overall accuracy, kappa coefficient is estimated to reduce the error due to chance agreement. Now what does 0.749 kappa mean? 0.749 falls in this category, means your classification is good. Had it been more than 0.81, the classification would have been excellent.